Hello student, this ENTC numerical is based on photodiode and the question is photodiode has a quantum efficiency of 65% when photons energy 1.5 into 10 raised to minus 19 joules are incident upon it, and question is at what wavelength is the photodiode operating, and second, calculate the incident power required to obtain a photocurrent of 2.5 microampere. This question is for 6 marks. So let's solve this question. The given information is quantum efficiency 65% and photons energy 1.5 into 10 raised to minus 19 joules. Photodiode operating wavelength formula is lambda is equal to hc divided by E. H is a Planck's constant, c is a speed of light, and E is the energy of photon. So H is a 6.626 into 10 raised to minus 34 and speed of light is 2.998 into 10 raised to 8 and energy of photon is given 1.5 into 10 raised to minus 19 in numerical itself. So if you calculated this, the answer is 1.32 micrometer. If you solve this answer, then it is for a 3 marks. Now next is the responsivity of silicon photodiode is a measure of sensitivity to light, where quantum efficiency is the conversion efficiency of photons to electrons of detector for a given wavelength, and Q is the electron charge, F frequency of the optical signal, H is a Planck constant. So if you put the values of all the things, so quantum efficiency is given in numerical 65%, that's why it is a 0.65. Energy of photon is given, then Planck constant and frequency is given 1.5 into 10 raised to minus 19. Answer is 0.694 ampere watt inverse. Also, the responsivity is ratio of photocurrent IP to incident line power P at the given wavelength. So we are using that formula to finding the incident optical power. PO is equal to IP divided by R. So IP is a 2.5 into 10 raised to minus 6 microampere mentioned in numerical and divided by responsivity 0.694. Your answer is 3.60 microwatt. So we are having the answer. Photodiode operating wavelength is 1.32 micrometer and the incident optical power required is 3.60 microwatt.